Welcome back. This is the demo for lecture number 2. In the first lecture, we talked about the constructor of the linked list. We implemented the constructor. We initialized the members. Then we implemented the add front member function, which adds a node to the front of the list. And we also provided a print member function to our linked list class so that it can traverse the whole linked list and print the values on screen. In the private section, we had 3 data members: the structure list node, which contains 2 parts, the integer data and the pointer called next of type list node. And we also provided a constructor with default values and 2 variables, one called size of type integer to keep track the current size of the list, and the last one is a front pointer, which always point to the front of the list. And today we are going to provide 3 more member functions. The first of these is called add. The return type of this function is going to be void, and its name is add. It's going to take an integer value and it has to insert this value to the back of the list, to the end of the list. So we talked about 2 cases in the lecture. The first one, if the list is empty, and the second, if the list is not empty. So let's handle the first case. How do we know if the list is empty? Well, if we say that the front is equal to null, that means there is no node and the list is empty. So in this case, we are going to create a new node from the list node structure. We're going to pass the value, and we want this node to attach to the front of the list, right? So we'll just create this node. The next pointer of this node is going to be null, and we will assign the address of this node to the front. So front is now pointing to the very first node in the linked list, right? And the second case is that if the list is not empty, so we have an existing list which contains 1 or more elements, nodes, and we have to start traversing the list from the beginning until we reach the last node. Once we are at the last node of the list, then we can insert a new value. So I'm going to create a temporary pointer. I'm going to call it current, and I'm assigning the address of the front, the value of the front, sorry. That means that the front has the address of the first node in the list. So we are assigning the address of the first node, but because front has that address, so we are assigning the value of the front to the current. What means is now that the current and front both are pointing to the first node in the list. So we'll have to say while the current node dot next is not null, that means this is not the last node, then keep traversing and update the current to point to the next node. So how do we do that? We're going to say current gets the value current dot next. As simple as that. I think I have misspelled the keyword while, so I'm going to make corrections. And once the next pointer of the current object is null, that means this is the last node. So we'll break out of the loop and we'll say current dot next should get the value or the address of the new node that we just created, right? Makes sense? Now once we do that, after the closing else block, we have to increment the value of the size variable by 1. Because whenever we want to insert a new node, what we do is we actually increment the value of the size, because size is that variable whose sole purpose in life is to keep track of the number of elements currently stored in the list. So now let's check this particular member function if it works. So we have a list. We added over 3 values, and the front value is 1, and the last value in the node in the list is 3. So we want to add a new value which is after this node. So we are going to call this add member function, and we say list.add. Again, we will provide the value 4. We have displayed the print 2 times. So I'm going to just comment out 1 line and run the program, and if we see 4 at the end of the list, that means the implementation of this function is correct. And as you can see, 1, 2, 3, and 4 has been appended to the list. So this implementation is correct. Now let's go and implement another member function, which is called contains. That means it's a search member function, and it's going to take a value and it will search that value in the list. And if it finds the value, it returns true. And if it does not find the value, it returns false. So the return type of this function is going to be Boolean. We're going to name it contains because most libraries these days use the word contains. And now we have to create a temporary pointer. We'll call it current. We'll assign the value of front while current is not null. Then check if the value of the current is equal to the value we are looking for. So I'm going to say if current.data equals the value which provided by the client. If this condition meets, we're going to simply return true. Else we have to update the current to point to the next node, right? And if we reach the end of the list, the while loop breaks out, and then we have to return false because we didn't find the value. So our list contains these 4 values, 1, 2, 3, 4, and let's after printing the list, we are going to say cout, and we're going to say list.contains, and we'll find the value 3, for example. So if it returns true, that means the value is found. If it returns false, the value is not found. And by the way, this bool alpha, which is a sort of operator that we can use whenever we want to convert the value of 0 to false and the value of 1 to true in C++, because the list contains will return a 0 or 1, the boolean value in C++. Bool alpha will convert that to the word true or false. So let's run this program, and I hope it returns true. And as you can see, it returns true. But if we are searching for a value that doesn't exist, for example, let's say 30, which is not part of the list. So let's run the program again. And now it says false. So our implementation of the contains member function is also correct. And now let's give it another small member function called getFront. And the purpose of this is going to be to just return the value at the front node in the list, right? It will not remove that value, but just return the value, whatever the value of the front node is. So the return type of this is going to be integer because we are storing integers in our linked list. And we'll say get front. And we'll first check if the list is not empty, because if the list is empty, that means there is nothing to check for. There is no front node. So if it is not null, then we're going to say, okay, return front.data. And that's it. So let's see if this works fine. So I'm going to come here and say the front value, and then I'm going to say list.getFront. And it display the value 1 because 1 is the front value, because we added 3 to the front, then we added 2 to the front, then we added 1 to the front, and 4 was added using the add member function to the end of the list. So now let's run the program. I hope it returns 1. If so, our implementation is going to be correct. And yes, the front value is 1. It's not font, it's front value. Okay, so let me make corrections here. So in the lecture, we talked about the remove front member function, which removes a node from the front of the list. So let's implement that function as well. After the get front, I'm going to come here and say void remove front, and this function is going to remove the value at the front of the list, right? So what we can do is we have to first check if the list is not empty, then we can remove the value from the front, right? So I'm going to say if front does not equal to null, that means front is pointing to a valid node. So then we can simply say that create a temporary pointer to store the address of the front. So I'm going to call it trash, and I'm going to assign the value of the front. So now the trash and the front both have the address of the first node in the list. Now it's safe to move the front to point to the next node, and then we're going to delete the trash, right? So how do we move the front? Front gets the value the front dot next. Front is moved to the next node. Front is now pointing to the next node. We can delete trash, and then we can decrement the value of the size because we have removed a value from our list. So now test this particular function. So we have these values in our list, and the value at the front at the moment is 100, right? Because this is the last call to add front. So whatever was front before is no longer the front now because 100 has been inserted to the front of the list. So now let's call this particular member function, and let me comment out these two lines so you don't get confused about different output statements. So I'm going to say let's dot remove front. So 100 is removed, and now let's print again. So see, this 100 was the front value before, but when I call the remove front and print the list again, there is no longer 100. So here we have a list. It contains three values, 100, 200, and 300. The front is currently pointing to the first node in the list. And now what we want to do, we will have to create a temporary pointer, and we will make it point to the front node of the list. And this function get will get an index and return the value at that index. But the interesting part is that we don't have an array in our implementation of the linked list, but we can create our own logic to do so. So let's see how it works. For example, these are the indices 0, 1, 2. There are three items. So the first index will be 0 and the last index is 2. So what we can do, that we want to get the value at index 2. So there is no array internally, but we can use a for loop starting from the 0, and we can compare the value of the counter variable 0 to that of the 2, and if it equals, we return this value. If it doesn't, we actually update the temporary pointer to point to the next node. So let's see how it works. So we are comparing the for loop 0 variable. Just understand this graphically. I'm going to explain and demonstrate that in the code. And if 0 is less than 2, no, it's yes, it's true. So we'll update the temp to point to the next node. And this is the second value of the for loop. So 1 is less than 2, yes, update the pointer. Now 2 is less than 2, no, 2 is not less than 2. So we got to that particular index, right, which is required by the user. So we'll return the value 300. No, right? This is the implementation. So we have a function called get value, or you can call it get. It takes index as argument. It should be integer. We create a temporary pointer called current, and then we assign the value of the front to the current. So both current and front are pointing to the first node in the list. We created a for loop starting from the 0, and it has to be less than the index. So for example, in the previous diagrams, we were looking for the value at index 2. So this index is going to be 2. So we say, okay, 0, I gets the value 0. 0 is less than 2, yes. Update the current to point to the next node, right? I plus plus 0 becomes 1. 1 is less than 2, yes. Update the current, and current is pointing to the next node. Then 1 becomes 2. 2 is less than 2, no. So we get out and we return the value at that index. So let's implement this in Qt Creator. So I'm going to go open my Qt Creator. So let's call this function get value, or you can call it get. It's going to return the value. So I'm going to say int get value, and it's going to take index. And then we are going to get a temporary pointer called current, assigning the value of the front. So I'm going to say I less than index, and then update the current to point to the next node, right? and it will loop as long as the value of I is less than the index which is passed by the client or the user. So once we break out of the for loop, we are going to simply say return current.data, right? So now let me test this particular member function. So I'm going to comment out these lines. So we have a list, and that list contains the value 100, 1, 2, 3, and 4. And now I want to call this member function. So I'm going to say cout list.getValue, and I'm going to pass the index 0, right? So it passed the index 0, which is the first value in the list, 100, because that front was called uh, for 100 last time. So 100 will be the first node in the list. And if this get value returns the value 100, it means our implementation is going to be correct. So let's test this with different values. Run the program. And if we get the value 100, yes, we got the value 100.